All right, so without further ado, maybe I just give the time to our second presenter. Okay, so Jianjun, get ready.
Okay,
Okay,
so I will
yeah, you can start.
present my screen. So can anyone see the screen, my screen?
Not yet. Okay, the screen is up.
Okay, so I'm presenting. So good afternoon to Dr. Tan and Dr. Razin and my fellow classmates. And today I'm going to demonstrate how to do the example 8.1 in the SCIA engineering. So when you download your SCIA engineering, you have this icon in your desktop. And also, when you open your SCIA engineering, you can the interface is almost like this because I haven't pressed the new button yet. So if you want to create a new file, you press the new button, and it will comes up an interface like this. This is the project data, and then also for the first and foremost the stage, I need to press the steel. I need to select the material, and then also after I selected the material, I need to set the unit to metric format. This is very important. And also after you set the unit, we are going to set the parameter over here. So I will somehow create a new parameter over here. It will assign a very weird name, a random name. So I can assign this as some parameter 8.1. So you can see we need to assign the E modulus over here. To be tally with our example, we need to change it to 2.0. Then the Poisson coefficient is 0.33. Then after you have finished changing this, you can press OK. And also as well, you can assign your name as example 8.1. And also, it's very important to change your structure over here. There are many different types of structure over here. I will choose the wall XY rather than the plate because the plate XY cannot define the loading with along the side of the plate. And this I will choose the wall XY. So I press OK. You will need some time to load. Okay, so I'm in the project folder. First of all, to model the plate, I need to create the line grid over here. This is the main tree for us to do the modeling. We will do the modeling from the top to the bottom. Yeah. So the first one is to select the grid. So if I select the grid, I will do the 2D line grid and rectangular grid. It's more easier for me to model the rectangular. Also, when you press the rectangular grid, this one will comes up, and then you can press 4. Because for our project, we have the 4 for the horizontal distance. And then you press 2 over here. This one is the vertical distance. So you have a 4x2 grid over here. So you press OK when you're confirmed. Then you press OK again. The grid will come out. So you can place anywhere for your grid. For me, I will put at the center of the project. So this is your grid. Then you'll press back the main of the tree. I'll close this first. So I will start designing my 2D plane. First of all, I will go to structure, and then I will go to 2D member. Then over here, this is the 2D member we want to assign. So first of all, I will choose the plate over here. This one is just for the filter purpose. And then the material, be sure to select your parameter, this one. So after that, you will need to define your thickness. Your thickness over the example 8.1 is 10 millimeter. So you can put 10. Then press OK when you are confirmed. And it will become something like this. This, just like the AutoCAD, you can draw anywhere you like. For this project, I will draw a rectangular. Until here, be sure to enclose your plate so that it becomes the red color, and then you press escape. So the plate has already been defined over here. Then if you want to see the geometry of your plate, you can press over here, render geometry at the bottom left of the interface. You can see like this. And then you can press Control and right click so you can turn the orientation, rotate to see the thickness. Is it correct or not? So you press over here, it will go back to the plan view. Okay, so after that, when I have already modeled my plate, I will choose the boundary for here. Over here, the model data, the support is in the model data tab. So I will press model data and then press support. And then our support in example 8.1 is at the line on 2D member edge. So I will press this. Over here, you can define your support manually lah. Depends on you want to be fixed, hinge, or custom. Is you can play with this. So for this example, I will choose hinge. As just now, just like the Lusas, my rotation is free. So I press OK. Then I can select anywhere I like. Then for this project, I will put over here. And then I will press escape. So the support is already modeled in the software. Okay, so after I define my support, I will define my loading. Go to the main of the tree, and then the loading tab will show. And then you will press the loading tab. After that, you need to define your load case. You define your load case over here, the 3 dots over here. Therefore, the default of the SCIA engineering is it will put the self-weight at the first, because this one is an analysis program for the structure. So usually they will put self-weight. And then for this case, we don't need the self-weight. Therefore, we just press it and press standard. And then you can describe anything you like. For me, I will describe dead load 1. Then I will press close. Then the setting is already saved. So for the example 8.1, there are one line load on the edge of the plate. Therefore, I will press line force and then press on 2D member edge. So this line load actually is depends on the global axis. You can see here over here, the X is horizontal, the Y is vertical. Therefore, direction, I will choose Y. And then the value, I will choose -5. So the loading will become going downwards. And also the value is kilonewton per meter. Therefore, I will put 5 instead of 5,000. So I press OK. And then just like the support, I can click anywhere I like. For the meantime, I will put it here. So if it is uneasy to see the loading is this big, you can go over here on the top. You can change the scale. You can change to very small so it looks prettier, I guess. And then if you are already set your scale and your loading has already set, you can go to the main and you can close the load instead. Then for the next step, I need to check my structure. So over here, I need to press check structure data. And over here, I need to press check. This is a must for the structure design because usually the structure is very large and we need to check our structure so that the error will be shown before our analysis. And also, if you have more member or more other member, you need to press the connect member or nodes. So I will show you and press OK. It says no nodes and no edge has been connected because we only have one plate. If there are many plates, this one is actually required. Okay, so after this, we'll define our mesh. Unlike LUSAS, this SCIA engineering only can define the average size of the 2D element. Therefore, for the meantime, I will choose 1 is a 1 meter, so it will be like a square. So I will press OK. And then after this, I will press mesh generation. And then 8 nodes add 8 element has been created, and then 15 nodes has been created. Then I will press OK. After this, I will press calculation. And then press calculate. And we need to wait a while. All right, so the calculation has done. It will come out with the rough data just like this. It will give you the maximum deformation and maximum rotation for the analysis. Then I will press OK. After this, you can view your result over the result tab. And when you need to see the displacement, you can either press 2D member or 3D displacement. It's actually the same because I already chose the wall for the project. Let me show you. So we has already choose the wall XY. Be careful not to choose the XYZ because this XYZ, it will consider the Z height for your structure, so that you need to restrain your Z so that the result is valid. Okay, so come back to our result. For this, I will put 3D displacement, and then over here, I will select the plate. And then go to the right hand side. I need to select my load case. So this situation, my load case is 1, and I will choose UX. And then for the system, I won't change. And then Extreme 2D, I will put global as an initial. So deform structure, I will untick later. Then when you press refresh, the result will come out. This one is the color spectrum for your deformation. If you don't want to have the deformation shape, you can always untick the deform structure, and then you press refresh again. Then it will be placed nicely in the plate. So over here, another selection, this one is additional. You can press this for the node. This one is for the every node with no average, because this one over here got 4 elements over here. Then if you are choosing in node average on macro, it will divide the 4 data for the element, this element, and it will comes up with the value of the deformation over here. So I will show you another one for like smaller element. So for smaller element, I will go to the mesh setup, and then I will reduce my size to 0.1. This will give us 800 elements. And if I go further down, it will become more. But for the recommendation, I recommend do not go further than this, because this will create around 80,000 elements, which is too many. So I will press 0.1 and I press OK. And then I will press the mesh generation again. Over here, you can see there are 800 elements over here. Then I press OK. Then I will press the calculation again. This one is a must for every analysis. It takes some time. Okay, so the analysis is done. I press OK. And then I will go to view my result over here. And I will select this element and press 3D displacement. And then with the previous selection, and then I will press refresh. This diagram will come up. And also, you can view from the bottom table results over here. This one is the result for the X, and this one is the result for the Y. But you can see over here is a very less decimal place. Therefore, we need to change the decimal place into at least 4 or 3 decimal place. So I can go to the top here below the 3 and the setup. And then this will comes up. Also, I can change my deformation decimal length. For this, I will press 4. I will press 3 just to be tally with the example. So it will become invisible again. So I will refresh again. It takes some time. Oh, sorry. Yeah, so it will comes up with the deformation with 3 decimal places. Then if you want to find the detail of any nodes over here, you can always change your extreme 2D to mesh. So when I change it and I refresh, and it will take longer time, but I think, yeah, just need to wait a while.
Now the wait a while is a few seconds. Last time is a few hours.
Yeah. All right. So over here, you can see every node, every value for the nodes for every element. So if you don't know where is it, the node, you can press the number over here. It will show you the X. Maybe I can press over here. Yeah, it will show it anywhere you press. So if you are searching for anywhere, you can press this filter bar in table. Then you can simply put anywhere you want to find, 0.5, 0.6, then it will be somewhere here. Yeah, so it is very convenient for you to find any value. So I need to show you the convergence for the. Okay, I will press back the global to see the maximum. Okay, over here, we can see the value. Okay, so the value for the x direction, this node is over here on the top. So D5 okay, over here. Okay, so D5 is the x direction, D17 is the x direction, this one is the y direction. So over here you can see the data is actually matching 0.62, 0.62, this one over here, 0.62, 0.62. And also you can see the y displacement, negative 0.193. This one is 0.192. It's a matter of maybe for some decimal places. So it will have a little bit slightly different. So if you want to see the stress, you can also go to 3D stress. Then you need to press the low case. You need to press basic magnitudes. It will come out with the basic stress we learned in the FEM. And then press this. This one is the stress X. And we press refresh. So it will come out with the stress diagram. Then over here, you can see the stress for the X value, for the Y value, and the stress for the X and Y value, which is the shear stress for the member. So after finishing everything, you can go to the file and save anywhere you like. Yeah, just save anywhere you like. So I think that's all for my presentation. Yeah.
Okay.
Mm.
Thank you, JJ. I think that is a very good presentation. If you have to compare with my presentation, at least you finish the race. I start somewhere in the middle. Okay.
So I will stop sharing my screen for now.
Okay, yes, no problem. So any questions so far or maybe comments from the floor?